Get on that.
Fritz is on the
I have a
fritz.
feeling you're gonna get other than something.
I appreciate it.
Fritz is on the fritz.
I'm on the first.
How much did we miss? We were out there.
Nothing, we haven't done anything.
Oh, okay.
We're just playing.
Crash and burns.
Oh, I gotta set an alarm.
What I know. Oh, I did.
In 30 minutes, you
Oh.
can register.
One thing, some of you guys were out, but this is a pretty cool website. It's PHET simulation.
What?
And
I've never seen that before.
we show you,
What do they do? What happens?
hang on, circuit construction. So some of you were watching me do this a minute ago. It's PHET interactive simulators.
Do they do advanced stuff?
Do they do what?
Circuit construction.
Advanced circuit construction?
Yeah, this is advanced. I don't know how more advanced you want to be. These are fairly basic. Advanced for me or for you?
For me.
Yeah, these are all advanced for you.
Rapid wire.
Okay, so here's, and some of you were looking at this, I'll just do this real quick. You can grab a battery and bring it out. You can grab a wire and you can connect them.
That's a wire.
That's a wire. Those are electrons waiting.
Oh, okay, they're electrons.
So I can add a bulb, another wire. I can put a switch in here.
It's a wire on a wire there. Or no, battery. It's attached to the battery.
Yeah.
So when do you want to use a capacitor?
So I can close the switch, the light comes on.
Electrons are flowing.
I can right click on the battery, change the voltage, bump it up.
Oh, wow.
I can take a resistor and I can change the resistance value to whatever I want.
Oh, yeah, that's cool.
And like here, I could split the junction and open it and put the resistor in there.
Okay.
I like this.
And I can actually put, if I wanted to, make a little parallel circuit. So I'm going to parallel this. Is the bulb going to get brighter or dimmer?
Dimmer.
It's gonna get brighter.
Brighter,
Yeah,
correct. Because I'm opening another
The
path.
resistance will go down.
And you
You
can,
know, that's all we need for lab, right there.
yeah, and see, this is, again, like here, I can take this, I got a voltmeter, and I can take my lead and I can put it on this one resistor, get my voltage drop. My leads are backwards because I got a negative.
Negative, yeah.
Oh, wow. I
Why don't we
like
just do
it.
that for lab? That's way easier.
That's,
And I can get my voltage drop.
Instead of hooking everything up, yeah.
Signing off, that's lab 7.
There's
Yeah.
my voltage drop
Can we do
across
that
my
like
bulb. And I can verify my battery. But see, my resistors are parallel to each other, but they're not parallel to the battery. It's a little
We like
different.
that, but.
Oh, no, I guess, yeah, I think that's, yeah, no, we're right, we're the same. The resistor's not parallel, or the bulb isn't. But you can take readings, you've got capacitors, inductors. There's a few more things, current charge.
What's the inductor do?
Inductance. Inductance.
You know, an inductor is like a coil, like I think what you're gonna get is a magnetic field.
The new iPhone 8 is going to charge via inductance. Where you just lay it on top of it.
Yep.
Don't plug it in anything. So it's a transfer of power, right?
Okay, so I've got some,
So is it? I think you're gonna try to get rid of they're talking about getting rid of all the buttons on
Yeah.
there.
Home button.
So does it?
so I don't know, I think that's just a coil. I should be getting a magnetic field, but I don't know how I'd measure that with the, but that's pretty cool.
Can you show the value of that coil?
I can I can do the voltage drop across.
No, but I mean if you right click, remember it shows.
And
It gives you the option of
seems to
changing.
be changing.
Seems
I
to.
don't know what it's doing.
Looks like it increases.
I can remove that resistor. So there's some interest. It's kind of cool. I will show you. Let's see. That what we were laughing at a little earlier was the John. What was it, John? voltage. So I can rub his foot on the rug,
And make electric.
and I can move his hand closer to get to move. And I can move it further away. So in order to get it to flow, I've got to really go. Yeah, and if I get closer, then I don't have to
Kick it so much.
kick as much.
Yeah.
That's Johnson Bolton.
Pointing to his hair.
Oh, yeah.
What about this? Where's the teacher?
His hair should stand up. You know.
Yeah, that's probably not gonna happen.
Got it.
It might. It depends on the way they programmed it. But see, it's built up, and I stop. You can stop in front of the door, and that's when you. But it's gonna happen quicker than that. But there's some neat stuff in there.
That should be our lab.
Johnson voltage.
Johnson Bolton.
Okay. So here's your final for lecture a week from tomorrow. Name 3 primary subatomic particles. Did they add the word primary? So again, proton, neutron, electron. We just started. I'm just showing you guys what the test looks like a week tomorrow. Which unit of measure is resistance? So we get that one again. That was the same one, ohms. Show a value, and that's not it in engineering notation. So far, nothing new. I'm still getting metric notation when asked for engineering and vice versa.
841 is 10 to the 3rd, right?
Yes. And then I've got some examples. And then there's this one again, and it's probably the same one. So nothing new there. And then what color code is something K, and it's probably going to be K, plus or minus 10. So you give me the colors. What is the resistance? What is the value and tolerance or percentage of a resistor with their violet, yellow, red, and silver? Again, those aren't going to be the colors. I've changed them. What are the possible minimum and maximums for the resistor in the previous question? 2 resistors are connected in parallel. Both are whatever. What's the resistance total? Any problem with that? If they're the same and there's 2 of them, it's just half that. 3 resistors are connected in series across a 40-volt source. They're in series. Total current is 40 milliamps. Resistor 1 is so many ohms. Resistor 2 is so many ohms. So you're going to have to figure the total current.
So the current is now 4 milliamps.
The 3 resistors, yeah, the total current is 4 milliamps. So you've got,
The current is internal.
yeah, 40 volts. So really you just draw, you're drawing that a series circuit, and you can do the grid, and you have one resistor where you don't have a resistance, but you've got the current, right? The current's going to be the same through all of them. It's series, and they're giving you 40 milliamp current. So you can do the grid with this, and each resistor, 1, 2, and 3, are going to be 40 milliamps, and the voltage will be the total, and you figure the voltage drop for the 2 that you have resistance for, right? And you'll get voltages for those, and you subtract those 2 voltages from your total voltage. So if you just do the grid, I mean, if I lost you in that explanation, do the grid and say, okay, what do I have and what do I need? Okay, so a circuit consists of 3 resistors connected in parallel. There's a 25 ohm and a 18 ohm and a 25 ohm. If the current flow through R2 is so many amps, what's the voltage across another? So they're parallel. So you know resistance and current for R2. And those 2 values will give you voltage. And it's parallel. So the voltage is going to be the same for all of them. You following me? Nothing new? A 12-volt source is required to furnish 600 690 milliwatts to a parallel circuit consisting of 4 resistors of equal value. What is the value of each resistor? So this isn't really any different. You take your voltage and your milliwatts and you get your total resistance. And then that was the problem we did before. Once you've got your total resistance, invert it and divide it by 4 and invert it back. And you've got your answer.
Can you go back to the last one real quick?
A circuit consists of 3 resistors connected in parallel. So they're giving you, it doesn't matter, they're giving you all the resistors, but the only one you care about is R3 and R2.
Right.
R2 is 18 ohms in this example and 3 amps, so that'll give you, you can figure the voltage drop. And it's asking you the voltage drop for R3. So once you get the voltage drop for R2, you've got all the voltage drops because it's parallel.
Yeah, thank you.
You have a parallel circuit with 3 resistors, a 15, a 110, and a 120. If you measure 120 volts across the 120 ohm resistor, what's the current through the 15 ohm resistor? Okay, well, it's asking you the current. What's the current through the 15? So you'll have to take the 1200 resistor, okay, it's the voltage. So the voltage is going to be the same for all of them. So now you've got a 15 ohm resistor and 120 volts. All you have to do is figure current. So really this one is, the trick is this one is remembering once again that parallel circuits are all the same voltage. And then you have this one. This is, it is mixed, it's not all, but you just did one of these. You guys all did quite well. But you've got a current on this path and a current on this path. You've got R1, which is out by itself, and R6 out by itself. So once you add these 2 currents together, you've got these currents in your total current. And these 2, R3 and R5, share the same current as R4. So you've got, right off the bat, all your currents. And then you take all the information, you're going to have 2 values for everything except the 2 currents, and you'll be able to figure the voltage drop here. We've done this one. You guys, it's nothing new for the one. It also asks if R1, if R2 opens, what's your total current?
Sorry, could you go back to the one where we had to do voltage squared divided by power? I didn't know that one.
Was that a particular question that you recall?
Another one. Some more. Yeah, right there. So it's 12 volts squared divided by 0.690 watts. I always mess this up or something.
Now you can do that, and here's your other option. You take your volts and your power, you divide power by volts, and you've got current.
Was it current?
So now you come over here and you've got current and you've got volts. And volts divided by current, you've got resistance.
Oh, so you just do that way anyways.
So you can do it this way.
So
This is why I have these up here, because these 2, if you remember these 2, you've got 90% of this memorized.
So 0.690
In fact, the only 2 that you cannot do that with, I think, are these that have the square in them. I don't know about those. I think these are the only 2. So I think most of the other instructors are going to expect you to have that memorized.
We'll get a tattoo.
What is the point of a Darson ball type galvanometer attached to? A small pivoting coil of wire and a field of a permanent magnet. When measuring voltage, how is the meter connected in circuit? When measuring voltage, is it series or parallel? It's parallel, because I want to see one of those words, series or parallel. In fact, yeah. Does anyone not understand what that's talking about?
We're measuring voltage.
When you're measuring voltage, voltage is always measured parallel. So when I measure the voltage drop across a resistor, I'm at the beginning, at the front end, of the back end of that resistor. That is parallel to that resistor. If I'm measuring the battery, I am positive and negative. I am parallel to that battery. If it's an ammeter, it is series because I break the circuit and I install the meter as part of the circuit. That is series. Okay, draw a symbol for a resistor. Draw a schematic symbol for a lamp. I don't know if we've covered symbols yet or too much. I think it's tomorrow night. But either anything like that. Most of the ones that I see look like this. I see that more than anything.
That's in the book, right?
It might even be in the book. Those are the only two symbols you have to draw, a lamp and a resistor. Why is stranded wire used in an electrical system? Anyone remember? We did this early on, I think. Why is stranded wire, multiple wires?
Actually, yeah, specific magnet.
Flexibility, longer flex life. So you've got landing gear, you've got wings that flex. Landing gear, you've got anti-skid sensors. You've got some proc switches that depending on the aircraft for the lock linkage. So those wires are constantly moving every time that gear goes up and down. Landing lights. Your landing light that's retractable has a wire that moves with that lamp every time it moves. So that's where you've got the stranded wire. Name one desirable characteristic of an insulating material. Name one desirable characteristic.
One desirable characteristic.
A desirable characteristic for aircraft wire. A desirable characteristic. So what do you want it to be able to do?
Flex, waterproof,
Oh, fucking. we're thinking of
flame resistant, moisture resistant.
All you gotta do is name one. Resist water would be the same as moisture resistance. Fluid resistance, because you've got greases, hydraulic fluid, abrasion, cut through, high temp, flame resistance. Flame resistance because there's maybe times when we have fire, and we want to still be able to control engines and systems while we get that thing on the ground quickly. We don't want to lose our systems too fast. We'd rather not lose them at all. So any of those are a desirable characteristic. You only have to name one. What's the maximum number of terminal ends allowed on a terminal stud? And I don't even remember seeing this in the material. A terminal stud is where you've got pictures now. A terminal stud is where you've got a bolt, a threaded bolt, and you have a loop with a wire on it, and that goes down there and you've got a nut goes on top. So wired terminal lugs should be used to connect wiring to terminal block studs or equipment terminal studs. No more than 4 terminal lugs. So this would be a terminal lug, just like some of the battery connections. Battery cables in your car. Some of those are like that.
Like a DC bus should be connected to it?
That would be a terminal lug on a bus. So a bus would be a strip of metal with bolts on it, and most of the time they're grounds, common grounds. So no more than 4 terminal lugs or 3 terminal lugs and a bus should be connected to any one stud. So the stud or the terminal stud should have no more than 4 connections. I think there we go. I did have pictures. Those are example of terminal studs. You might just have one. This was typically one that would be hot because you can see the ridges on it on the top prevent, if something were to fall on it, a conductive material, then you don't get an arc. What is used to neutralize lead acid battery or electrolyte spill?
Bicarbonate soda.
Okay. Electrolyte spillage can form grounding paths. Let's see. Clean up these surfaces with distilled water and dry the area. Let's see.
So the vinegar dilute or just for your
Are they giving us 2?
So it depends on what it's for. It's
While
for-
handling the caustic potassium hydroxide electrolyte, wearing safety goggles. Technicians should also wear plastic gloves. In case of spillage on hands or clothes. Vinegar or dilute boric acid solution, 1 pound or gallon of water. Okay, a solution of bicarbonate soda and water is my note for the boric acid. And that, what kind of acid spill is that? Lead acid. So lead acid, you can say bicarbonate of soda or baking soda, the same thing. Either one of those would be a correct answers.
Texas for the
It's for different batteries.
battery,
Yeah,
yeah.
yeah. So that one, I'm seeing that.
That's something else.
That's my mistake. Sometimes these were late hours when I was putting these together. What electrolyte is used in a nickel cadmium battery? So I just have them out of order. What electrolyte? No, that's,
Potassium.
yeah, that was spillage. Okay, so potassium hydroxide or KOH.
KOH.
That's the electrolyte for a NiCad.
Potassium.
Okay, what does the abbreviation AWG represent? American Wire Gauge. I think that comes up in the presentation tomorrow night. American Wire Gauge, also known as Brown and Sharp Wire Gauge. Standardized wire gauge system since 1857. The larger the number, the smaller the wire. It's counterintuitive. And that's it. That's the whole final in this class. So there shouldn't have been anything in there that particularly worried you.
Are there diagrams we come across?
The only diagram, you mean as far as the
Mesh circuit.
the closest you're gonna come, you mean one of those? That's the only one. Just the one series parallel. And you guys did pretty good on the last one.
Will you be posting grades the next day or that night? Or?
I'll post them, I will probably post them that day. Usually while I'm sitting here, you guys come in to filter out. It'll take you, I expect everybody to be out of here within an hour on that Thursday.
Yeah, I gotta think with your mom after next week.
So usually I'm sitting here entering them immediately. I'll show you this guy again tomorrow night if you want. And, you know, we've still got, I just want to give you a heads up so you can start thinking about what you want to do and where to go. So we're back. We're in lab for the rest of the evening.